We did. It was super fun. Wasn't it fun?
It was. Yeah. I enjoyed it.
So yesterday what we did was we were trying to figure out how much energy is lost to thermal energy when you're dealing with some Hot Wheels, right? That's what we did yesterday. So at the lab station, they built, so there was a post here and a post here, and they moved the posts or whatever, depending on how to build it. And what they did was they said, okay, so we're going to start it here, and they're going to run it down. Okay, that's what you did, yes? That's correct? And the goal here was to release your car from here so that it just, when it got to the top of this hill, it was just moving just a tiny bit. So basically, just enough speed to get over the hill. Now, here's a thing that I think is important, okay? We obviously, if you've seen videos of my children, you know that we watch a lot of American Ninja Warrior at home.
Very true.
What's that?
Very true.
And one of the things they always say is, they say two things. They say, oh, his momentum carried him over, or he didn't have enough momentum to make it up this hill. None of those things, neither of those things make any sense at all. We're going to talk about momentum in a week or two, but they just misinterpret the idea of momentum and speed. It's all about speed, okay? So if I want to get over this hill, I'm going to say he didn't have enough speed to get over the hill, which is a fine way to phrase it. You didn't have enough speed to get over the hill because you had a lot of speed at the bottom. You slow down as you go over. So what we're saying here is at the bottom, I didn't have enough speed so that I would get over the hill. That's what they're saying. Is that cool? You guys with me on that? Because if you look at the bar charts for this, so bar chart for the beginning, bar chart for the top of the hill. So we have some gravitational and some kinetic energy. We don't have any elastic here. Okay? This is our system, so we have the cart and the G field. So here, you have all gravitational energy. Who is sending me messages while I am teaching? Okay? Now, what do you notice about the height of this compared to the height of this? What do you notice just looking at the picture? Go ahead.
The road's lower.
It's lower. The second hill is always lower. So if I start with 3 here, I can go with, or 4 here, I can go with 3 here. All right? And where did the energy go? Had to go somewhere. Okay? That's right. It gets kicked out of the system because the car either rubs on the track or rubs on itself, and we lose some to some thermal energy. Now this is fine. What this implies is that it's not moving here and it's not moving here. That's fine. In order for this to get over, it has to be moving a little bit, but you see right. Is that cool? And then what the kids yesterday did is they measured the height here. They said, what's my initial height? And then what's the height here? Oh, we'll make this one out. We'll make this a little h, and we'll make this one a big H. Is that cool? All right, so this is what they did yesterday, and this was going to give them a very specific way to say this is how much thermal energy was lost. Is that cool? Because you can just calculate the thermal energy, or you can calculate the gravitational energy. It's equal to mgh, true? And you can calculate this one here. Eg is equal to mgh. This one would be the big H. And if you know this is how much you started with, you know how much you had when you were here, you can figure out how much you lost to thermal energy. Does that make sense? Today we're going to do something exactly the same, only different. Here's what's going to happen today. We're going to go back to the lab. All right, what is happening? My telephone. It's very annoying. Here's your post. And we're going to start the car here. and it's going to run down onto the table. Is that cool? Nice and straight. Look good? Now, what is the energy situation in the beginning? Okay? What is the energy situation in the beginning?
Gravitational.
Okay? All gravitational, I'll buy that. And then in the system, we have a cart, energy field. Circle. What's the situation over here? What's the final situation? Go ahead, just add a lot.
Maybe we want to thermal and then it's gonna be 30 kinetic.
She says it's going to be kinetic over here. And then, now, what we're going to do is we're going to explore today how much energy is lost. So, here's the deal. How do you calculate the gravitational energy? Right? Lucas, what's the M in MGH?
Mass.
Good. What's the G value, Sarah? What's the G in MGH?
Gravitational.
Yeah, it's the gravitational field strength. It's right on the wall, true? What's the H? L, what's the H?
Height.
It's the height. So what you're going to do is you're going to set this up and you're going to measure it and you're literally going to calculate it. Okay? Does that look good? Now, what about the kinetic energy? How do you solve for kinetic energy? 1/2 mv squared. Right? Mr. Lotta, what is the M in 1/2 mv squared?
The M.
What's the M?
Mass.
Mass, good. What's the V? Andrew, what is the V?
Velocity.
It's the speed, right? So it could be the velocity, but in this case we don't care about the direction, so it's the speed. Okay, this is the part that's going to be hard for you, so you need to focus. Are you ready? How are we going to get the speed? Well, think about speed, like the speedometer in your car. How do you find that the everyday example, like how do you find the speed of anything? What two things do you need to know? Distance and time, right? What is it in your car? It's miles per hour, correct? So if you want to calculate the speed, you need to take the distance a car goes and divide by the time. Is that cool? So here's what you're going to need to do. You're going to need a stopwatch, and you're going to need a ruler, right? Stopwatch on your phone, there's rulers at your station. When the car gets down to the flat section, you're going to measure this distance here, and you're going to take the time while it's on this flat part. Now, what you're going to want to do is you're going to want to start the time when it's up here when you let it go. Don't do that. I only want the final amount of speed, not the average speed over the whole time. Is that cool? So, you're going to measure the height, you're going to calculate the MGH. You're going to get the speed here using this. Then you're going to do 1/2 mv squared. So you're going to get a value for this, you're going to get a value for this, and you're going to subtract to get a value for this. Does this make some sense to you? Now, you're like, all right, Don, that sounds pretty good. How am I going to construct this thing? Well, here's what we're going to do. All right? And your very first thing was, kids don't want, I know it's my fault, but you don't need the computer today. Just turn it on. So I don't know how to throw it very well, but the answer to your question is yes, but I cannot throw it. It has to do with two things that I haven't practiced well, and that's the arm angle and the wrist snap. I haven't been able to master either of those. And it's super annoying, because every time you throw it, it goes like 100 feet away, and then you gotta like go get it. And that's super annoying, so I haven't practiced one. All right, so what you're gonna do is you're going to get one of these whiteboards over here, and you're gonna take it to your station. There's a box, whiteboard markers in it. This is a box with little red rag erasers in it, so you can erase a whiteboard if you need to, and I will have to find whiteboard markers. And literally, I have no idea what they're doing. Is that funny? All right. So that's what you guys are going to do. Does that sound good?